You are about to see how the weather affects our planet over a complete year. It's the 1st of March, 2019, the beginning of a meteorological spring in the Northern Hemisphere. Let's start the playback. Every 2 seconds marks a day, another complete rotation of the Earth. At this time of year, tropical cyclones form. Ocean currents form a giant circulation system around the planet, transferring heat from the equator to the poles. Our atmosphere is always on the move. It's constantly flowing from one place to another. Across the planet, continuous cycles of rising and sinking columns of air help to create our weather and define the type of climate in each part of the world. But what causes these air currents? They fundamentally rely on the land and ocean that's near the equator, receiving more direct sunlight and becoming warmer than places further away. Hot air rises, and this helps lift water vapor evaporating from oceans into the atmosphere. As it cools, the water vapor condenses to form clouds. These can grow to become showers or thunderstorms, which can be seen. Every year, the seasons bring regular changes to weather patterns across the planet, but there are other naturally occurring patterns that, whilst not as regular, can still have major impacts on people's lives. They can occur over periods of time, ranging from months to decades. Climate Station's weather year coincided with one of these, a fluctuation in sea surface temperatures called the Indian Ocean Dipole, and that happened to be one of the strongest on record. The Western Indian Ocean became much warmer than usual. The extra evaporation caused extreme In the middle of the last century, few people were interested in climate change. Levels of greenhouse gases in the atmosphere were unknown. Temperatures were being recorded, but no one was assembling them to make an accurate global picture. At this time, a young researcher called Charles Keeling was working out a way to measure the level of carbon dioxide in the atmosphere. He found concrete proof that as the level went up and down with the seasons, it was also steadily rising. A few scientists had already said this was likely. Burning fossil fuels rapidly releases millions of years of stored carbon back into the atmosphere. And it was concerning. Have you ever wondered if climate change is affecting where you live? In the observations section of Climate Station, you can find out. The temperature of the planet is rising, but in some areas it's rising much more than others. The Arctic is warming more than twice as fast as the rest. The Earth's atmosphere contains 78% nitrogen and 21% oxygen. The other 1% is made up of greenhouse gases, such as water vapor, carbon dioxide, methane, and nitrous oxide. That tiny 1% is crucial for regulating our climate. Without greenhouse gases, the Earth would be far too cold to live on. They act like a blanket, keeping the planet warm. As with the glass in a greenhouse, they help to trap the heat from the sun that would otherwise radiate back into space. So why do we want to get rid of them? Because human activity is rapidly increasing the levels of greenhouse gases in the atmosphere. This is heating the planet beyond the level that many plants and animals are accustomed to, and faster than they can adapt. This shows all the main contributions humans make to our climate, representing both warming and cooling effects. The main greenhouse gases are highlighted, with carbon dioxide having the largest warming impact. Since parts of the world became industrialized, the level of carbon dioxide in the atmosphere has increased by a staggering 50%, and the increase is accelerating. By using methods such as analyzing samples from the bottom of the ocean, we now know the level hasn't been this high for at least 2 million years. It would be even higher if some of the extra carbon dioxide hadn't been absorbed by the land surface and oceans. Methane is the second highest contributor. There's around 200 times less of it in the atmosphere, but it's much more effective at trapping heat than carbon dioxide. Since pre-industrial times, its level has more than doubled. In fact, it's risen an astonishing 10% in just the last decade. By far, the most abundant greenhouse gas is actually water vapor. It's created by evaporation and removed by rain. The amount of water vapor in the atmosphere varies with atmospheric temperature. For every what might the rest of the century be like for our planet? As the Earth warms,